Mode.
Good morning and good afternoon, as the case may be. This is Jim Raffle with Colormetrics Technologies, and we are here for the Color Control Myths and Mysteries Lighting and Viewing with GTI Graphic Technology webinar this morning, or this afternoon. So we will get started. We do have a little bit of housekeeping to take care of. So apologies there. I have to have my mouse in the right spot. So today we're going to have a three-person panel. Myself, Jim Raffle, the CEO of Colormetrics. Shelby, why don't you introduce yourself?
I'm Shelby Sapusik. I'm the project manager of Colormetrics.
And Bob, go ahead and let everyone know who you are.
I'm Bob McCurdy, and I am Vice President of Sales and Marketing with GTI Graphic Technology.
Great. And Bob will give you a little more information about his company in a few slides here. So,
so you know, all of our attendees are in listen-only mode, and that's so that we can get through the presentation. However, you can type in your questions or comments in the control panel box on the right, and we will get to them. If it makes sense in the presentation, we'll stop and answer a question, but we might wait until the end. So we're going to try to save some time there. Also, throughout the presentation, we'll be asking some poll questions. You'll see this slideshow go away. You'll be asked to answer a question. It'll be multiple choice, and then we'll share the results afterwards.
Great. Thank you, Shelby. And also, if your question is unique to just you, we may type an answer back to you so that not everybody has to see it.
Some of you might have seen this graphic before in our color control myths and mysteries presentations. We always talk about the door to consistent color. We know that we want to have a consistent color, and we're all trying to strive to get there. So what we're seeing here is maybe the top red is our target, and we're getting either the middle or the bottom colors, and we're just trying to get those to match. So that's our goal. So our agenda today, we're going to do a really quick color viewing quiz. We love to start with those. We're going to talk about what D50 lighting is. We'll talk about monitoring your viewing conditions, consistent supply chain color viewing. We'll talk about metamerism, and we'll have because it's Valentine's Day, we thought it'd be fun to do a Valentine's Day red mystery, and then we'll have some time for Q&A, as I mentioned at the end.
And you got to stick around for the Valentine's Day red mystery, because that's our final poll question. It's kind of a fun one. All right, so let's get started, though, with a kind of a color quiz. And my question for you, are these images different or the same? So I'm going to let you guys look at that for a second before I pop up the poll question, because otherwise you won't be able to see the images. All right, so while you look, I am going to get ready to pop up this poll question. Whoop. Okay, select poll. There it is. And I'm going to launch the poll. So you should all be seeing the poll question, and we're waiting for your answers. And it looks like about half of you have answered, so I'm going to give you a couple more seconds here. I think some of these people have been on the webinars before because...
well, we can't trick them anymore.
I know.
We'll have to come up with some different ones.
We're getting too smart of an audience. We've taught them too well. We'll have to start changing our quiz questions. All right, we're just about to the point where I'm going to close it. If anyone else wants to answer real quickly, I'll give you about 5 more seconds. And there we go. So let's share the results with you. I hate this one, I can't see it. But basically, you can see that 67% think it's the same, and 33% think it's different. So what I'm going to tell you right now is it was a trick question. You're both right. Both sides of you are right. So what we've got is we've got one of Bob's viewing booths, which provides for 3 different illuminants, and we'll talk more about that further in the webinar. So these 3 images are exactly the same. They're all 3 photographic prints, and if you look at them under the same lighting conditions, they're identical. But if you look at them under different lighting conditions, they are not identical. So I think in that way, it's safe to say you were all right.
So we want to take a minute here and just congratulate Bob and GTI for celebrating their 39th birthday. And if you're not familiar with GTI, Bob, can you give us a little bit about your company?
I sure can. Indeed, we're still putting away the empty bottles caused by celebrating our 39th year in business. GTI is a family-owned business. We design and manufacture our products in that building you see, and that is located in Newburgh, New York, which is 60 miles north of New York City, and enjoyed about a 16-inch snowfall yesterday. So it's quite pretty and North Polish at the moment. Our products are made here and sold through resellers around the world. We also have offices in Germany and the UK. And inside that building is besides manufacturing, is a radiometric laboratory where we test critical components and designs and viewing systems. And the markets that GTI relates to, obviously printing, graphics, photographic imaging, in addition to industrial color applications like paints and plastics and metallics and textiles and automotive. Really any industry that needs to exercise tight color control and needs to please demanding customers. And demanding customers generally express their opinion based upon what they see. So that's why the visual is so important. So wherever you find color being important, you should find a lighting system that's tightly controlled, and that's what our company's mission is to provide that. And after 39 years, we've learned a lot. We know a lot, but we know we've got a lot more to go. So we're pretty pleased.
Okay, so you've talked about lighting and standards, so why don't we pop up your first poll question for the audience? And it is, do you know what the lighting standard is? So we'll give you guys a chance to answer this one.
And actually, I think I might add the lighting standard that pertains to graphics, print, and imaging.
Right, that's a very good point.
Other markets have different standards, yeah.
Good point.
And we're about half of you have answered, so we'll give you about 10 more seconds here because we don't want to cut into Bob's presentation time too much, but I think it'll help him to know the answer. He may tailor his presentation differently as a result. And I think we're going to give you about 5 more seconds. I don't really have a stopwatch here. I'm just doing it in my head. So, all right, we'll close the poll and we'll share the results with you guys. So 67% of you say yes and 33 no. That's actually, that's good. It means we've got some people here who can learn some things, and I'm sure even the people who know are going to learn a few things because Bob's got some great information to share. So let's get on with it.
Did you notice something, Jim, that that's the same ratio that had answered that the prints are the same or they're different? So
that is interesting.
So this slide, what is D50 and why is it important? That's a great question, and I have to pat myself on the back for thinking of such a fine question. But one of the things is, have you ever heard of D50 and what does it mean and is it important? And you'll see the line, smaller text says, D50 equals ISO 3664:2009 standard. And I guess I should have put a question mark there because D50 is actually a illuminant specified by CIE, the Commission Internationale de l'Éclairage, or the International Commission on Light. And D50 is one of the illuminants that they have published, which is very well defined, and it represents an average daylight condition based upon measurements that were made pretty much around the world in an overcast daylight condition. So the D does stand for daylight because it is a simulation of daylight, and indeed it is the illuminant that is embedded into the ISO standard. So I guess the question of does D50, does that mean ISO 3664:2009 standard? It does, if somebody is referring to it that way, because it is a key ingredient to the standard, but it actually doesn't because it's one key ingredient out of many. So you can actually talk about D50 and not be referring to all the elements of the ISO standard. And in fact, you can have a viewing system where your D50 light quality is on the money, but the other elements are off, and you will not enjoy the benefits that this ISO standard is developed to deliver. So I can walk the line, and yes or no is the answer. Is it the same or is it not? And in this case, depends upon who's saying it and what they mean. So what is D50? And I think the next slide will show us a graphical picture. The D50 again is a CIE illuminant, and it specifies a spectral power distribution. And what you're seeing here is the plot of the data that is presented with D50. It's how much energy is being emitted by a light source at every wavelength in the visible spectrum, which is visible spectrum 400 to 700, ultraviolet is below 400, and that is, there is UV in daylight, and there is UV included in the CIE D50 specification. So when the standard says, you know, I would like to have, you need to have a D50 light quality falling on your print, what they're saying is you want to have a light source that has a spectral power distribution very close to that curve that you see falling on the print. There are several ways that they will allow you to test and quantify your light to make sure that it's close enough and it falls within certain parameters. But frankly, and those are important because you can have a light source that's rated at sort of D50, but doesn't do a very good job emulating that. So again, the standard has metrics that you use to test it. And if we look at the next slide, we'll see one of the commonly found fluorescent light sources that is delivering a D50 light quality onto a press sheet. So you'll find this in a lot of viewing systems. And what you're looking at is the blue line is the CIE D50 standard illuminant, and then the black line is the simulation brought to you by a fluorescent light source. This particular light source actually has a very high rating of one of the metrics, which is color rendering index. However, as I look at it, and as GTI looks at it, its variations above and below that D50 curve shape are causes of concern, and in our opinion, mean that it does not replicate the D50 as well as you can. When we build a viewing system, the first thing we do is start with a lamp that we have designed and built to meet this D50 spectrum. And if you look at the next slide, you'll see our latest spectral power distribution overlaid on top of the D50. And again, those spikes of energy that you see at about 430 and 550 nanometers, those are called mercury lines, and they're present in all fluorescent light sources. The mercury is there in order to start the arc so that the fluorescent lamp can initiate light up and start fluorescing and emitting light. So those are very common. Your eye integrates those so that you don't see massive problems due to these mercury lines. However, they're very easily identifiable. All fluorescent sources have these mercury lines present. And here what you're seeing is something we refer to as goodness of fit. You know, how well does your light source fit the spectral curve shape of the CIE illuminant that you're trying to replicate? And again, that's something that we place a very high value on. And even though this is we think is a very nice, close-fitting spectrum to the D50 target, the color rendering index is not as high as the previous light source that we were looking at. And that's actually because of how you calculate color rendering index and the fact that it uses colorimetry and basically also the effect of these mercury lines in those calculations. So anyway, the bottom line is D50 is that colored in spectrum. Our particular lighting system is the magenta line, and it's we think it really does a great job, and it meets all the key metrics of the ISO standard as far as color rendering index, also chromaticity, and where in color space the light falls. Now there's a lot of interest in a new technology. You've all heard of it, and that's something you're going to find at on your headlamp. It's an LED light, and LED lamps are indeed getting a lot of money invested in them. It's an exciting new technology. It's got a lot of very large companies looking at it for a variety of reasons. But when it comes to trying to match the D50 spectrum and have a light source that renders colors in a very highly compatible way with existing systems and new systems that are providing D50, if you look at the shape of this particular spectrum, this is a viewing system that does meet the parameters of the ISO standard. So it's indeed, you can purchase an LED source that's D50. However, looking at the shape of that spectrum, there's no question that color rendition looking at pairs of colors and looking at colors, they would be rendered significantly differently than the previous two slides that we were looking at. So it's difficult to think that a printing company would be benefited by bringing in a new technology D50 viewing system that renders color differently than their current ones. Not to say that in the future this is going to be the technology of choice for daylight simulation, but presently the state of LED design and manufacture is it's a big rush. Everybody's going off in any direction, and when you talk to somebody who's in the LED business, the first thing you hear is that whatever you want, we can give you, and that's because they really don't know what you want. In this case, you've got a quote here from a doctor with Philips Lighting, and they're learning, they're referring to what they went through with the compact fluorescents, the CFLs, and the fact that they are moving very quickly, but there's a lot of testing and research and standards that need to be in place before LED lighting can truly reach its potential and become a viable source, particularly for critical applications like color viewing. Obviously, LEDs are great for cars, and they're great for closets, and they're great for headlights, and they're really finding a lot of applications. But in terms of trying to recreate daylight in a accurate manner, LEDs are still kind of new and developing. And that slide kind of shows you the burning the candle at both ends, which I thought was pretty good.
Right. We're going to pause really quick here, Bob, because we want to introduce another poll question. So, Jim, if you don't mind. This one is, does your substrate have OBAs? And I'll be interested to see what this answer is, because I'm curious if people are going to know what OBAs is.
Well, we can tell them optical brighteners. So.
You could have said, oh, bah.
Isn't it an oboe? Oh, wait. I guess that's me not being able to read. All right. We got about half of you, so I guess I'll do my standard. We'll give you about 10 more seconds to answer our questions. And, Bob, you're going to be very impressed by the breakdown, it looks like.
It might end up being the same percentage. It's close.
Which is great, because that means we've got a third of you that are truly learning new things, and that's the whole purpose of these webinars. All right, so about 5 more seconds, because several of you haven't answered, and you've all done a good job answering in the past. So I'm going to have to close it out, though, right about now. And let's share the results so Bob can properly actually, a higher percentage didn't know than last time. But that's great, because I think that leads into your next slide really well. So let's hide those results. Let me get your next slide up for you. There you go.
Yeah, and actually, it's a good question when you think of, trying to answer, does your substrate have an OBA? That's almost a slightly tricky question, because is your substrate what you're printing on? Is your substrate what you're proofing on? Those being two different sheets of paper usually, and one might have it and one might not. So I realized that that was a bit of a tricky one. And if you answered yes and you know you've got optical brighteners, that's good. That means you probably have come across them or have thought about how best to either view them or consider that in your calculations for color corrections. If you said no, then that means you're probably buying a paper specifically with OBAs, with low or no OBAs, which is good, but it can run into a problem if that paper is in a workflow where you're going to be later on comparing it to a sheet that does have OBAs. And the reason that could be a problem is that the ISO standard recently, and in standards parlance, recently is 2 years ago. Actually, it's 4 years ago. 2009, they published a new standard, which took about 2 years for the manufacturers to design products that were complying. And the primary change between the year 2000, that publication date, and the year 2009 was the requirement to come closer to the UV portion of that CIE D50 spectrum. Whereas before, the requirement was you were allowed to have a metamerism index of 4, which is basically you could achieve a match to the standard requirement by having zero ultraviolet energy in your light source, and a lot of lamps had very little or zero ultraviolet energy. The new standard dropped that down, and when you think about metamerism index, best way to think about it is it's a average delta E of 3 pairs of colors that in this case are being activated and responding to UV energy. So the average delta E previously had to be 4, which sounds pretty tight, but it actually, for lighting, it wasn't. That was dropped to 1.5, which is much tighter and did require more UV in the light source. So the lamp that you were looking at moments ago showed you a batch code at the end of the lamp near the logo. If you see that, it's circled in red. It says HSE, and that E at the end of that code tells you that this lamp was designed to meet the 2009 or the current version of the ISO standard. Previous lamps from GTI ended in an X or had no third letter, and those would have been made to comply with the previous. And again, the difference isn't anything about the D50 color. It's really about how much UV is in that lamp. And if you've got a lamp with the ends in E and meets the current standard, the difference between a brightened sheet and an unbrightened sheet, one with OBAs and one without, is far more dramatic. And we've seen that can cause issues if you have proofed a job with OBA-free paper and then you're running the job on stock that's got a lot of brighteners. All of a sudden, your proof and your press sheet visual match is not anywhere near as good as it used to be.
So have we pretty much answered this one, Bob?
Yes.
Okay.
Why is it important?
Yeah, it sounded to me like you sounded.
Actually,
all right. So
actually, the next slide tells you why it's important.
Well, now I think it's my turn to talk again.
Oh, okay. Sorry, Jim.
No, that's fine. That's what the little J on the bottom is. My turn. So the reason I'm doing this slide is because I started the presentation with a very similar image. Bob has updated the woman that they put in the light box apparently, but this is the same light booth with the 3 light sources. And now that Bob has explained to you what the spectral distribution curves look like, it's kind of neat to see them above the image of the light box. So daylight fluorescent, which is what Bob did a great job talking about early, is the middle. So that would be the D50 lighting standard that is applicable to our industry. However, on the left, we've got commercial fluorescent store lighting, which is where a lot of our print and packaging products end up. So you can see why sometimes we think we hit the color right on, we as the printing and packaging industry, and our clients are looking at it in a boardroom or a viewing room that simulates their store lighting, and they're going, no, you're way off. And then, of course, the consumer takes it home and to their incandescent lighting, and it looks entirely different yet again.
And I know you can't really see what this looks like, but let me tell you that this light booth is very impressive in person. Bob and GTI was nice enough to let us borrow pretty much this one, I think, at a conference in November in Florida. And I can't tell you how many people came up to us and were just talking about the difference in lighting. We were turning it on and off, and it's just really impressive in person. So if you get a chance, they're neat.
Yeah, Bob can tell you what trade shows he's going to be at if you haven't seen it. All right, so back to you, Bob.
Thanks. That's true. Actually, the woman upgrade between the early in the slideshow and presently is we average about 20 years with a single person's picture there. We wait until the first word out of anybody's mouth who sees it at a trade show is, "Oh my God, do you still have that person's picture in the color vision demonstrator?" and then we, by popular demand, we'll switch it. The interesting thing, though, on that last slide is, looking at the 3 images and how they're so significantly different in color appearance, you understand why the industry said, hey, you know what, if the customer is going to be in Manhattan and the printer is going to be in Tennessee, the only way it's possible for them to actually see the same color is if they have the same lighting environment. So that's kind of a key reason why a standard was developed to enable the ability to communicate between different locations rather than all having to stand in one spot to make color judgments and to talk about what you see color-wise. So you'll see that the next slide is the title of the standard, and the primary reason that standard was developed was communication between people in different locations, so they could confidently know that when they look at a color, their vendor or their customer is seeing, pretty much nearly the very same color. The other characteristic or goal of the lighting standard is when I do a color match, I'm visually checking to see how well I'm holding my print to a signed proof or a target color. I want a light source that's going to render color no matter where the critical color is in the spectrum. I want to be able to see it, and if there is a difference, I'd like to be able to see that very easily so that I can go back and check to see if there's been a change in print conditions that I need to address. So a light source that has, it's almost like having glasses that have the right prescription. When you've got a proper viewing system, it's going to make you more sensitive to subtle color shifts. That's the goal of the standard. The next slide is actually showing you that the standard, as you can see, and actually if you can see that, Annex A in the standard is a summary of all the various elements that are specified, defined, and recommended, actually required in order to meet the standard. And embedded in there is that CIE D50 aluminum. I can kind of make it out on the lower left side of the red oval. But you can see there's other elements as well that have to be in place, because you can have one of the, we say there's 5 basic elements that are required to have a proper viewing system that meets the standard. There they are. And color quality is, I would say, probably the most important, because color rendition is determined by the color quality of the light falling on that press sheet. Color quality being the spectral power distribution, but also is defined by the chromaticity. And later on we'll show you some targets that show you where the standard chromaticities put you and what the allowable tolerance is around it. Also, color rendering index is part of the color quality equation, and metamerism indices. So color quality is obviously, extremely critical. However, light intensity plays a big role, as does light evenness. Geometry of illumination doesn't sound like it could be a problem until you're staring at a metallic, a highly glossy sheet, and you're having a hard time seeing the images because there's glare on that sheet. And a simple change in location of the overhead light fixture or angle of the viewing table would give you this really nice, flat, easy to see, image to make visual comparisons. So they've written into that standard that the geometry should be such that you've minimized glare. What happens sometimes when somebody's minimizing glare is they can have that light fixture installed in such a way that they have no glare, but their light evenness is extremely poor from one side to the other. So they've introduced another area where they're going to see differences that aren't really there. And then finally, surround conditions of the viewing system. That is our favorite color, which is gray. It's a Munsell N8 gray. The standard actually, in this latest publication, they created a range of grays. So Munsell N8 is at one end. It's a 60% reflectance. It's a pretty light gray, but they allowed you to go with darker grays. And from our standpoint, after 36 years of shipping systems that are a specific, reflectance of gray, it's hard to go to your customer and say, you know what, you can have a darker gray. The standard's changed, and what difference will it make? And the fact is, it makes a big difference. So all of these things have to be right in order for you to benefit by having, the ability to look at a print in your shop and know that your client is seeing that same print as long as they're meeting this standard. And it is an international standard, so the client could be in Europe, the printer could be in Asia. It's one standard worldwide, so it really can deliver a lot of benefit. And it's not very difficult to get it right, but actually it's very easy to get it almost right, and that's where people have problems that come up in communicating with their customers.
And Bob,
So
I think
again,
this is
5 elements.
I think, not to interrupt, but I think this is a good time to launch our next poll about this standard that you're talking about. So we're going to do that. We just did. Do your viewing systems comply with the standard, this ISO standard?
And, oh, we're going to have a little different. Oh, Bob's going to. This is neat. We're watching the percentages come in here, and about half of them have answered. I'm not going to give anything away yet, but it's different. How about that? It's significantly different than the last poll questions.
99% say yes.
You're wrong.
Yeah.
We have a lot of people admitting that they don't comply with standards, which is great. I mean, that's awesome.
About 10 more seconds.
Yeah, I think actually, that's about the percentage. I think we're going to close it here. I'll give you guys 2, 1, close. All right. So yeah, it's almost 50-50. Bob, you got some customers out there, it sounds like, or potential customers.
That's good. Well, the funny thing is that that's not the easiest question to answer, because to answer that question, you need to, either have a device that you just measured it with, or you've had somebody come in who had that device and measured and surveyed it. You might think that because you've got, I don't know if anybody's seen they used to be called REM indicators, and now GATF sells them. They're little adhesive back strips that are 2 colors, and it's what's called a metameric pair, and they're designed to look relatively close or very well matched under a D50 or a daylight source. And then as you switch to maybe a cool white fluorescent or an incandescent source, you get some really dramatically differences in those 2 colors. And it's a neat tool. It's a neat phenomenon. It's the idea of a printer putting this strip on a proof and sending it to a customer, and if the customer sees stripes, then you absolutely know that there's no way you're meeting the standard. You're not going to see the proof at all the way the printer is looking at it or the way the standard specifies it. The problem, though, is on the lower left you see the words one-way indicator. It can tell you that you don't meet the standard, because if you see stripes, you don't meet the standard. But it can't tell you that you do meet the standard, and the reason it can't is because, number one, it's really reacting to the spectral shape of the light source, and it will actually have a very nice match under a D50, a D65, a D75. Really any light source that's got a nice daylight balance, they will have a nice match to. So in terms of, am I at 5,000 Kelvin or the D50 spec, they could match under such a broad range that you really could be under any of them and you'd see a good match. Also, the intensity, 2,000 lux is the target. These could match under 1,000 lux. They could match under 3,000 lux. So they're great to say no. They're not possible to say, yeah, that's a good standard. Really, the only way to do that measurement is to take a device and measure the light falling on your copy. And what is the device that's most likely to be sitting in your facility? I would say if you look at this graph and look over on the right-hand side, you see there's a number of I1 Pros that were used to measure, and then we had a Color Spider, which is actually more of a monitor calibrator, and then we had a DTP94, which is also more of a monitor calibrator, but each of them has software and will be able to measure light. And the problem is that out of these 19 devices, measuring one light booth held in position so the geometry of illumination and pickup did not change, you can see that they didn't agree overly well with one another. And in terms of passing or failing this light booth, you're looking at a chromaticity plot here. The circle in the middle is the tolerance circle of what's allowed by the ISO standard. And the magenta square is actually the radiometric measurement that was made of the booth that we know is correct. So I think if you hit the next slide, you'll get a zoom in on the graph, Jim. And here, again, you can see on the orange ones, those are the spiders. 1 out of 9 said it passes, and 8 out of 9 said it failed, and failed in a big way. The blue diamonds are the I1s, and 3 said it passed and 3 said it failed. And and the green ones, the DTP94s. Maybe more said it passed and fewer said it failed. The problem is that the one you've got in your shop, when you go to measure, you have no idea where it's going to measure, so it's really not capable of being used as an absolute device to make this measurement. The second problem is that in the standard itself, they specify the type of device that you should use, and it needs to be a radiometer with a 300 to 760 nanometer range and a 5 nanometer maximum band pass. And you won't have one of those lying around the shop that's being used for color measurements. These are unique products designed for light measurement. We actually have obviously a good number of them in our lab and in our production QC, and also traveling in the field. So it is possible to actually have somebody come in and bring a device like that. And devices that have specifications that will let you make this measurement are now on the market for anywhere from $5,000 to $8,000, and they're relatively portable. They are accurate. They've got very good resolution. So, if you have a lot of viewing systems and you want to be able to make your own measurements, you can, spend $5,000 to $8,000, and then you need to make sure you monitor it properly and know what the numbers are telling you. So it's not as easy as it seems like it should be. And here, this is just showing you in color space where D50 is versus D65, and what the chromaticity tolerances are, what the target is and what the tolerance is. And we're going to show you in a minute that when we go in and do a report and show you, you've got 10 viewing systems, let's see how they compare to each other and how they compare to the targets and the tolerance of the standard. We're actually showing you, at least in color space, a small circle around that D50 target up there.
Okay, and I think we want to give them a poll question here, right? So
yes,
we're going to ask them about relamping. Let me launch this one. So our question is, when was the last time you relamped? And we've got a couple answers there. So we'll give you guys all a chance to weigh in.
One of the more popular relamping techniques is the power company coming in and saying, hey, we'll do this for free, and you're going to save money, and we'll come in and switch out bulbs and ballasts and reflectors. And I'm sitting in an office that was done too, and that's good because I don't do a lot of color viewing in this office.
That's not the ideal way to do it, though. It doesn't sound like. All right, this is. Well, we're going to close it, and you can look at the answers here. I'm sorry, I'm getting a little lag. There we go. So, about an even third. You've got about a third that did it in the last 12 months, which is one way to do it. Obviously, you're going to tell them that there's a better way than just a calendar one. About a third it's been more than a year, and you've got a third admitting that they're really not sure. So we've got an honest audience here today. This is awesome, and I think
they're winning an award, I'd say.
Yeah. So we'll turn it back over to you. I think this is where you want to be, right?
So, yeah, exactly. This is a case where we went in and audited a printing facility, and in this case, you're looking at a zoomed-in view of that color space, and the inner circle with the black line is the current tolerance of what should the color of the light be, which is also the chromaticity of the light. And the outer circle, the blue one, is the previous tolerance, the ANSI, which was an American National Standards Institute specification, which is now part of the ISO standard. So you can see it's quite a bit larger. So looking at this printing facility, if we were talking the old standard, which actually goes to pre-2000, they'd have most of the units meeting the spec and a couple of them not meeting the spec. They'd be off in the yellow direction. However, today in 2009, after 2009 rather, they've got 2 booths that are meeting the standard and a whole bunch that are not. And again, this was done before relamping. Once they relamped with the right lamps, they had far better color results. Everything fell within. Now, not every story goes this way. This one had to fight its way onto the presentation because it was so dramatic. because sometimes you'll relamp a viewing system and there's a problem with the viewing system. The ballast is bad, or the lens is the wrong type of lens, or the reflector material is distorting the output of the light. So you can put the right lamps in, and you might not nail the color chromaticity. But in this case, they were able to bring everything into a very small, tight cluster simply by cleaning and relamping their viewing systems. So it's an important positive step to make. We're going to show you on the next slide the same story, only in this case we're talking about intensity. 2,000 lux is the target for the aim, and you'll see two lines. Plus or minus 250 lux is the preferred tolerance. Plus or minus 500 lux is the kind of outside tolerance. And in this case, you can see that 3 out of the 13 viewing systems are on the bright side, so they're falling just outside. But on the high side, which is not usually, I'd say we usually find the lamps are less output than more. But going in and relamping, we find that what happened?
Oh, yeah.
No.
No?
Next one.
Next slide? Okay.
Next slide, that's what it is.
Yep, next slide. Maybe. There we go.
And yeah, and again, the next slide brings everything closer. Typically with lamps, and the reason you need to relamp is assuming you're starting with the right bulb. Sometimes when you've got high intensity, you may have a lamp that's rated for 5,000 Kelvin, but it doesn't have the same kind of smooth spectrum. And as a result, you get more light, but it happens to be more light that doesn't render color quite the same. So when you replace it with a proper D50 simulation, the efficiency is a little bit less, so the intensity comes down. The viewing system is designed to give you the right output based upon the output of the lamp that we're putting in there. So here you can see that just about everyone except the 2, except for locations, I think 6 and 7 or 7 and 8, got a straight line. But anyway, so you can see that relamping with the right lamp is a huge positive step, and it should be done regularly, and it's worth checking when's the last time you did that.
All right. So
we have another poll question for you about lamps. Do you know what lamp you installed and whether or not it conforms to current old standards, or are you sure?
Let's see how honest they are this time.
I'm going to go 33, 33, 33.
No, this is surprising. I love these poll questions. It really makes the webinar, I think, much more fun as a presenter because you're getting the feedback right during the presentation if you're providing good information. So we really appreciate you participating in the poll questions out in the audience because it helps us make these webinars better. And give you guys about 5 or 10 more seconds because it looks like got a little bit lower responding percentage. Come on, guys. All right. Looks like everyone who was going to respond probably has. 3, 2, 1. And so really, it looks like, Bob, we've got about 42% who do, and 47% aren't sure. And 11% are admitting they've got some of those old bulbs. And you know what? If I had a big box of bulbs in the warehouse, I'd still be using the old ones too for how much they cost. What do you suggest people do? Well, what would you do? What would you tell someone if they've got a whole box of the old bulbs still that we know they're not cheap? So I guess
exactly. It's a good question. They're not cheap, and frankly, there are interesting, some applications where again the primary difference between old and current is that UV, and so you might be working with like corrugated or some area where ultraviolet, there is no brightening in the paper, and you aren't using anything that's reacting to UV, in which case the old lamps are actually giving you D50 and they're hitting all the numbers. It's just that the UV that the change took place.
Well, that's great. So that's the reason we asked the OBA question earlier. Okay.
Right, exactly.
All right, so we're going to give Shelby a chance to talk again.
Well, I come from 17 years in the newspaper industry, 7 different newspapers around the U.S., and I was basically a production director, which meant I dealt a lot with press checks and pre-press, not only for the brand colors of the newspaper itself and the photos and images we used in the paper, but also obviously for advertising where brand colors were important. And I can tell you that there was no such thing as let's calibrate our monitors. We didn't have light booth. So our myth here is what you see on the screen, you'll see in print. And obviously my problem was I'm using this color in my designs and they're not matching the final printed product. And in a lot of situations, as the newspaper industry was going down, I also didn't have access to the actual printer. I was shipping things PDF to a printer, 200 miles away. So I couldn't do, in-person press checks. So Bob, help me out.
Well, we can help out on the lighting standpoint. Here's an example of prior to not having standard viewing or not having the correct lamps in a viewing system. What you were looking at in this case is a visual match between the proof and the press sheet at 3 different locations. And the big problem is you think it matches, then you go to your client's location and it doesn't. And that's typically caused by a different spectrum at the client's location, and that spectral power, again, could be UV or it could be just a different 5,000 Kelvin bulb that's got a very different way of rendering colors. So you're describing sort of a pre-standardized world, which is why the standard exists. So if we look at the next slide, as long as the standard is employed, you see far greater consistency in the proof to press sheet match. And that's really the thing, is you're making decisions based upon how well you're matching a proof. And if that comparison changes when you go to a different location, it's making your life very difficult and kind of you're chasing your tail. So the standard is designed to help in that capacity. Now, soft proofing has been really growing, and it's because the monitors have gotten so much better and are so much more able to render, gamuts that are in excess of what's on the ink on paper. So we've installed a lot of viewing systems that relate to, accurate contract level soft proofing. And in terms of the lighting system, what's different between a normal color viewing system, ISO standard, and one that's used for soft proofing is we allow the light intensity to be adjusted to match the luminance level of the monitor, again, to allow you to make a good apples and apples comparison between what you see on the screen and what you see on the print or the hard copy. This picture is showing our latest product introduction, which is a light box that actually measures the luminance level on the screen and then will automatically set itself to match, so that if you want to have consistency, automation, and use instrumentation to do that, this IQ product we call it, it's a SoftView IQ, lets you do that by pushing a couple buttons. Because if that match is tight, then you really start to develop confidence in your soft proof and know that if you're seeing differences and want to adjust, you can do it with confidence. So soft proofing has grown substantially in the last 8 years. This is typically what you'll see is a desktop system. Someone might be using Photoshop or proofing, but we've also put a lot of systems that go right on the press console. And if you look at the next slide, you'll see an example of I think it's a KBA press console. And in this case, that monitor slides back and forth because the viewing angle on the monitor obviously is different than the viewing angle on the paper, and so you want to be aligned with the monitor properly. But again, the overhead lights in that system can be modified to be brought down into tight luminance agreement with what you see on the monitor. And press operators have said that they get very, very good results without a hard copy proof, simply by working off the screen, the monitor, and matching the press sheet to it. So soft proofing has really come a long way, and the monitor quality has gotten so much better that it enables it for sure.
All right. Whoop, getting ahead of myself here. All right, so our myth was what you see on the screen, you'll see in print, and I think we've proven that yes, that's it can be done, but in order to do that, you need to do several things, and you need to basically working on a calibrated monitor, calibrated to a standard like D60 or D50. You need to have your printer, which could be a press or an inkjet device, calibrated using some form of system. G7 is one method that we're big fans of. You're going to need some instruments. Bob's talked about some. You need to measure light, to measure your light booth and also your monitor to get those two to match up. but you also need instruments to measure your finished print, which we'll talk about a little more at the end. And then you have to basically create a color palette, which that's really your answer, Shelby. But
Well, as I was saying, when I was working in the newspaper world before really all these standards were in place or at least used widespread, that's what my solution was. I didn't have a spectro, I didn't have regular monitor calibration, I didn't have those things available to me. So what I did do is I created a standard color palette for advertisers as well as the newspaper itself, and I would send it to the printer, and then we'd go back and forth with percentages until I got the color I wanted, and then I would send those to my designers and say, these are the only colors you can use because these are the ones that are going to print correctly.
great. So we're going to start another myth now, and this is that prints look the same in all lighting conditions. And I think you guys already know that's not the case. That's what this whole webinar has been about. We actually pulled this slide out of one of our earlier webinars where it was just a small piece. And this is we're kind of showcasing another one of Bob's pieces of technology here. It basically allows you to look at 4 different light sources for ink drawdown. So you can, this could be used both on, you could print out a big enough sample on an inkjet device or offset press, flexo, it doesn't matter. And you can slide it under this hood. And Bob, what are the 4 light sources? One's, I can't remember what the 4 light sources are.
You've got a daylight, you've got a cool light fluorescent, which would be a store light, you've got an incandescent, and then you've got an LED source, about 3,500 Kelvin, as sort of generically representing a retail lighting environment based on LEDs.
So what we're trying to show you here is that sometimes this problem can't be solved, but you can, with technology, you can show your customer how their brand color is going to look in these different light sources, because you can have your ink companies do everything they can to get pigments that aren't metameric, but depending on what your brand color is, it just may not be achievable. So you've got to have a tool like this where you can go in and say, look, this is why your brand color looks different in different places. Maybe it's time for a rebrand if that really bothers you, and pick a color that doesn't have this big shift. Back to you, Bob. You can talk about some of your devices and how they can help people.
This is actually, again, ISO standard viewing with 0 footprints, and it's an area that we've enjoyed a lot of success lately because A, the growth of wide format printing, and B, people do like to look at proofs and images in a vertical format so they can kind of step back and see maybe an entire campaign. We developed a special line of lighting products that combine a prismatic lens with a parabolic grid, and you look up at the bottom of that light source, you can kind of see darker areas. That's the parabolic grid that's actually directing the light down to the bottom of the viewing surface, or the viewing wall, and the prismatic is spreading the light, so you've got a combination of good top to bottom uniformity and very smooth coverage on the wall. So that's just a hot new area, really, is wide format and large format on a wall. So the next slide, I think, is just showing you, the standard has a part 2, which is actually a lower intensity, everything else the same. Again, the ISO standard part 1 is 2,000 lux, part 2 is 500 lux. For soft proofing, as a default value, they will say you should meet ISO part 2. So the IQ system has the ability to just get there with one push button. So that was, I guess, a commercial.
Excellent. Well, Bob, I think Bob's really done with his part of the presentation, so we want to thank him. However, Bob, stick around because we've actually got some good questions that have been typed in that we'll go right to the end here because it looks like we're going to be right on the hour. And that way, if people want to stick around for answers to the Q&A, they can.
But first, our Valentine's Day quiz.
All right.
Are these 2 reds the same?
We
and
promise.
Yes, we will launch the poll question.
What do you guys think? Wow, I'm a little surprised. We can still fool people.
Well, this is a new one.
It is new, yep. And this one, what's cool about this one is we created this. This is we're not borrowing someone else's optical illusion this time. We created one to kind of showcase what measuring color can do, and viewing it under the right conditions can do. So we'll close this up. So 67% of you think they're not, and 33% think they are.
As Jim said, they are not, they are different, but we actually scan these in ourselves, and this is a 485 red versus a 186, and we move them closer together. So hopefully, I know you're viewing this via the internet on the monitor, but hopefully you can see now that we've moved them closer together that they are different.
And when Shelby says scanned in, what we used an older I1 because I didn't bring my newer one on this trip, and we basically measured from the book the 485 swatch and the 186 swatch, and you can see it's showing a fail because what we did is we set the 485 as a reference and then measured the 186 against it, set a tolerance of 2 delta E, and it was actually more than 2 delta E.
That's a real photo we took yesterday.
It is. Yeah, it was in a hotel room somewhere. I can't remember where.
I want to see a newspaper with a date.
That's a good idea. So, and this is the screenshot you saw, or this is a screenshot of the screen that was in that image. The center of this color space is the 485 red, and the point out here is the 186. And hopefully you can read this. It's 9 delta E, almost 9 delta E apart. And we can show you all the different parameters you'd want, the LAB, CH. We can actually show you spectral distribution curves. And we show the two. This is where those two images came from. We actually take the spectral measurement, we render it in sRGB right in the browser window. So it's not perfect, but if you're on a calibrated monitor, it's a close approximation of the color that was printed. And so we just basically screen captured those two little blocks, and I cut them and sent them to Shelby. She split them apart in Photoshop or something and created that image for us. So those are real measurements from the book that I have along. It's kind of a neat example of what color verification and process control can do for you. And this is a brand color that many brands try and hit a red similar to this. So it's a great starting point.
So as always, our closing slide, so to speak, is how we've opened the door a consistent color. And as you can see now, all of the swatches are matching.
That's neat. All right, so we've had some questions. I think one person was asking how they can have Bob come in and measure all their booths and potentially relamp for them. And there is, I'm sorry, Bob. It looks like I messed up the slide. Your email, the R ended up on the line with the phone number. I apologize for that. So if you go down to Bob's contact information, there's an 888 number and then a letter R. So his actual email address is rmccurdy@gtilight.com. So you can contact him if you want to do that. And then this webinar will be posted well, you may not have gone to this page, but on our website, we have a GTI webinar page, and it will be there forever. And when this webinar is, when I get the recording processed, it'll be posted there and it'll remain there.
We hope by Monday or so.
Yeah. So now what we're going to do, Bob, is we've got new questions coming in, but I'm going to start with the people who asked during the webinar. We had a question, Bob. How reliable is the i1 Pro 2 with Babel color CT and A in assessing viewing conditions?
That's a good question because we haven't had a chance to use that device. But there's our experience with Babel Color software is actually, I think it works well. It's very nice in the way it presents the data and takes the data in. So I think that software is quite nice. I think the problem would be the device that you're measuring with itself. And I would say, based upon what we've seen, you can, if you go measure a viewing system that has actually been tested and certified and you kind of know what the values are, and then take your device and you measure it and see what results you get with your device and Babel Color, compare those two to see, number one, how close you are to absolute correctness, because typically that pairing can be used very well for comparative purposes. So if I've got 10 viewing systems, how do they relate to each other? Are some of them off in intensity, some of them off in color? But in terms of money in the bank, this is absolutely correct. I wouldn't trust a 10 nanometer device, which the i1s have typically are measuring in a 10 nanometer window, which is too wide to get a real good accurate value on a fluorescent light source.
All right, next question. This must be somebody who knows you. I think you told me this answer light years ago. I like the pun. But why on a lot of printing presses do they use D65?
You know, press operators, live healthy lives and they can be very old. The and the answer, that's getting to an answer that means that actually was the standard back in the 70s and 80s. Europe, it was more Europe used D65 in the press room and D50 in pre-press. Interestingly enough, in the United States, we used D50 in pre-press, and then we used D75 in the press room. D65 and D75 are both sort of slightly bluer shades of white. And back in those days, you were doing a lot of process color printing where you'd be laying down individual inks. The bluer the light source, the easier it was to see the yellow ink because that blue was increasing the contrast between the white paper and the yellow ink. So it was pretty common to have a bluer light in the press room. Europe basically dropped D65 from their lighting standard a good number of years ago with this ISO spec, but there are applications in industries where D65 is the standard, so you can still get those lamps, and a lot of times it's a European press that comes in and it's outfitted with D65, probably, I don't know, because somebody has been there a long time and that's the standard that they remember.
Okay. Will GTI ever make a lightweight mini version of CRD1?
We did make a lightweight, lightweight. We made a CRD2, which was about, I'd say, 2/3 the size. The problem is getting lamps that are that small. Even now, our CRD1, the daylight source in that lamp is not our graphic light D50 phosphor because we didn't have that phosphor put into these very small T5 lamps, they're called. They're very skinny. Just because that would require a large production run. So even now, the CRD1 is excellent at showing you how colors change under different light sources. It doesn't actually have a true, accurate D50 light source present at the moment.
Oh, I love it. Full
Anyway,
disclosure.
the answer is yes, we did make one, CRD2.
I love full disclosure. All right, so we have another question. You've got a lot of questions here. You're going to be on this webinar for a little bit. We use soft proofing. The luminance of our monitor is 160. What should the luminance of the overhead lighting be?
Oh, I think I know that.
And if you don't know, we can always answer that person in email later. So.
Yeah, you fixed it. And I say the reason I say I know that is because one of the earlier companies that developed software for soft proofing had kind of created a chart that they used. So that answer is there. I can't tell you off the top of my head, but I'm sure we can email it though, because there is an answer.
We'll get you the person's name and we'll get that out to you in email. How about the new X-Rite Exact for checking? I'm assuming they're talking about checking light boosts. Is it even capable of that?
I'm not sure.
Okay. So it's probably a better question for X-Rite.
Yeah, exactly.
Okay, that's just a thank you for the webinar. Are industry or standards organizations pushing for an LED version of D50 or D65?
I would say no. The industry, the way these standards groups work is the people that are willing to kind of dive in and sort out the issues and figure out what needs to be changed, that's sort of a diminishing crowd, and they aren't looking to create work. And I guess that being said, when LEDs are common enough and in use enough and accurate enough that they want to talk about how embedding that in the standard, I guess I'll step back and say they don't really care what technology you use. If you look at the way the standard's written, it's all technical measurements of light systems that has no requirement as to how you get there, whether with a fluorescent, whether with an incandescent bulb and a filter, or with an LED. So I would say they're sort of technology agnostic in terms of what you do to meet this standard.
All right. Well, that was it. That's our last question. Obviously, you've got contact information here if you want to reach Bob. You can find contact information for Shelby and I at the colormetrics.com website. We want to thank everybody for attending. We want to thank Bob for partnering with us and putting together an excellent presentation.
Yes, thank you, Bob.
Thanks, Jim. Thanks, Shelby, and happy Valentine's, everybody.
I love it. All right.
Thank you.